So getting started with Linux from scratch again. What is Linux? Linux is an operating system kernel. It handles the communication between the hardware and the software. It can't do much by itself, but if we mix it with some other software, we can make a full operating system. Operating systems that use the Linux kernel are usually called Linux distributions, or just distros for short. The reason why you want to use Linux is because it respects you using the computer. It kind of expects that and not the other way around, unlike some operating systems. Linux doesn't come with a bunch of like AI bullshit that they're trying to peddle out. It's just a kernel. That's all it does. It has one job. It's free as in beer, meaning you don't have to pay for it. You could just download it straight offline. It's also free as in freedom. You can do whatever you want with it. It completely respects that. Basically, you can do whatever you want with it so long as you let other people do the same with your code if you ever publish it. You always have to package it with the source code, things like that, or make the source code freely accessible. So it wants you to tinker with it, and I think that's sort of a hidden quality. People typically look for convenience, but I think that there's a lot of benefit to a computer that also lets you learn how it works. So that's what we're going to do today with Linux from scratch. It's a book, not an operating system or a Linux distro, but it takes you through building your own, right? And this isn't exactly going to be a system that we're going to use in our day-to-day, maybe in a few segments, but for the most part, this is really just intended as an exercise to learn how Linux works, how you compile it, what are the lower level pieces of software that tend to run with it to form that full operating system, because most people, right, they just install it and it works usually, and that's fine for the most part, but there are so many problems that can be fixed if you just know how your system works. We're going to do that with a software called QEMU, LibVirt, and Virt Manager. We're going to use a live CD, which works this time. I actually tested it, and we're going to use that live CD to give us a little bit of software to compile the stuff with, to download the packages with, all that stuff, basically to lay the groundwork for the virtual machine. So today we're going to partition the virtual machine's hard drive, create the file system, and sort of generally just do chapter 2 of the book. Chapter 1 is just sort of an overview. Chapter 2 is like laying down the groundwork. And that's it. We're going to get started. Set us over to the desktop mode. And if you want to make a new virtual machine, just click this here, install from local media, and then it'll give you like all of this other stuff. So it gives us all kinds of options. You can customize so much. So we're going to boot it up. So the first thing what we're going to do is live CD is a read-only environment. It gives you like a whole operating system to like mess around in, but none of the changes you make to it are going to be saved if you like reboot, which isn't much of a problem because Linux from scratch, like it's not intended to be done in multiple sessions. So what we're going to do if we ever have to pause things is we're just going to like suspend it. So from the virtual machine's perspective, we never really leave our session. So it doesn't really matter if it's read-only. Well, that's interesting. We're off to a great start here. As you can see, I'm very good at computers. God, why is my cursor sideways still? Okay, so we're not going to do that again. This is kind of quiet. There's an awful lot of dead air here. Why don't I fix that? I'm going to add a media source. Oh, wow, that's okay. We don't need it that loud. Much better. I'm going to start with $1,000 bets, I think. No dice. Wow, that's loud. We are on Kick. We're on Kick. There you go. See, and you just say that word, and it's like a magic word. Let's do a $2,000 bet. Ah, shit. Maybe we can make it back. Oh. There you go, massive win. That's what I'm talking about. Do they rig Flash games? Oh, massive win. And it only took me 5 tries. Oh, there it is. Okay, so it is doing stuff. I thought it was going to hang for like the longest time. Installation completed with an error. That's no good. The next page, building Linux from scratch in stages. Linux from scratch is designed to be built in one session. That is, the instructions assume that the system will not be shut down during the process. So that means this is why we're doing it in a VM and not like on my desktop onto like another hard drive. It's because we could just go here, click save, That'll save the virtual machine state, I think, and then we can just resume at a later date. That was kind of what I was talking about earlier. It doesn't mean it has to be done in one sitting. Yeah, we don't care about this. Creating a new partition. So now we get to actually start the Linux from scratch. I don't think we'll have to worry about swap space, but we'll set it anyway. See if I still remember how to use this. I don't. I do not. fdisk is a dialogue-driven program for creation and manipulation of partition tables. It understands GPT, MBR, SUN, SGI, and BSD partition tables. Maybe I should have read this part before reading this part, because I'm seeing boot. Highly recommended. Use this partition to store kernels and other booting information. To minimize potential boot problems with larger disks, make this the first physical partition on your first disk drive. Well, I think I already made the root partition the first partition, so, I mean, none of this is set in stone yet, but I kind of don't feel like going back and redoing all of that. So, out of 60 gigs, let's map this out here. We shouldn't be freeballing it. So we're going to go root, swap. So these are going to be all the partitions we're going to make here. I think this is a good order, right? Oh, maybe boot. Am I mixing this up? Is the grub BIOS boot thing? I think these two are the same, or intended to be the same, right? This is a learning process. This is a learning show. I'm the opposite of a Tech Pro channel. This is a tech. I want to say a word. I don't know if it'll get me banned. This is the DSP Tech stream. There you go. This is the Review Tech USA Tech Tips. Dicker's Tech Tips. So partition number 1, it's going to be our boot. This is for like grub and kernels and all that. Then we have a root partition, I guess. Then you have your swap. Then we have 3 extra partitions. We're going to have one for our source files. We're going to have one for opt, which is going to be more important for when we do the better Linux from scratch stuff. Or not better Linux, beyond Linux from scratch. That's like the next book. So Linux from scratch, what we're doing right now is like the base book. It makes like a base system. And then beyond Linux from scratch is adding on extra features to a base Linux from scratch system. So that's when you put on like a desktop environment and things like that. When we're going to be finished with this, it's just going to be like just a terminal, like it's just like text only, but we'll put the graphics and stuff on later in beyond Linux from scratch. I think we need separate ones. So we have boot partition. So we have /boot for number 1, the grub partition, the BIOS boot for number 2. Swap, I think, is twice our RAM, so it's going to be 32 gigs. Now our budget, 60 gigs, so we have to keep that in mind, because we're already up to like 52 gigs. There's not going to be much else left. Do we need that much swap? I feel like we don't need 32 gigs of swap. Shit, dude, I might need to make a larger hard drive. Weighing things here. Because if I reboot this, if I make a new hard drive, or like resize it or whatever, I'm going to have to reboot this live CD. And we're going to have to reinstall all the stuff again. Maybe 60 gigabyte hard drives are not something you should pair with 16 gigs of RAM. I mean, so here's the deal. I have 128 gigs of RAM. You know what? What am I doing? What am I doing limiting myself? You know what we're going to do? I've decided. So we're going to shut her down. So see, when I said I prepared more, what I should have said was I prepared more compared to the last stream. Because I should have had this. I should have already done it. Well, I don't know. There is a conflict of like goal, right? Because this isn't as much of an instructional video as it is learning with me. I think is part of the fun of the live stream, is you're learning with me, and then I guess later on the channel, because I do have a YouTube channel, that's where the more instructional content could be like refined and placed onto, I guess. So we're gonna do 2 things. First, we're gonna go to our virtual machine here. We're gonna up this fucker to like 64 gigs of RAM. We're gonna crank that bitch up. 32 gigs. Actually, no, 64 gigs. I bought 128 gigs. I'm gonna use 128 gigs. CPU, I mean 32 threads is fine. Probably shouldn't give them all the cores. I don't know how that's gonna affect OBS, but we're gonna have a ridiculous amount of memory. Oh, is this gonna blow it up or swap? Is swap even gonna matter when you have 64 gigs of RAM? Are we even gonna bother with the swap partition? I think there's like a special club that you get into where when you have 64 fucking gigs of RAM, you don't need swap space anymore. Because we're not gonna hibernate this computer, we're just gonna save the state on the host. I do have swap on the host, I think. 64 gigs is fine. We're not even gonna bother with swap. So 200 megs for boot, 1 meg for grubs partition, 20 gigabytes for the root partition, 50 gigabytes for source partition, 10 gigabytes for opt, and then whatever remainder is just for home. I'm going to try not to look things up if I don't have to. Man pages are fine, but it's a bad practice, I think, to just like Google everything. You gotta work your thinking muscles a little bit. You gotta think, actively train yourself to think for yourself. So if we don't know, we're just gonna figure it out. We're gonna experiment a little bit and make mistakes. Okay, so we have a disk in the folder that I wanted. There you go. See that? 100 gigs. No swap. Maybe that'll cause problems. Maybe not. This isn't an instructional video. So we're gonna boot up our VM again. All right. Probably good to have extra RAM anyway, right? If we're gonna compile a bunch of stuff. We're gonna reinstall all of our tools. I think the coffee's really kicking in now. I'm not even looking at the numbers. Gotta win $40. Massive win, $400. What are the odds it's gonna go red again? We're gonna do a 5K bet on black. Oh, it's okay, we can go all in. Massive win, 11K. Okay, let's go. No! We're gonna make it back. Yes! We're gonna go another. No! Dude, come on. No! Oh my god. No, my god. Oh. Oh my god, dude. Come on. 10. No, I lost all. God damn it. I'm getting like dizzy. Dude, this coffee's getting me real dizzy. Or maybe it's because I lost. I was feeling fine a second ago. That's fine. Okay, what were we doing again? Partitioning. That's right. So we're gonna add a new partition. We're gonna create, I guess, GPT partition table, disk label, I want to say. Then we're gonna make a new partition. Partition number 1. Our sector is gonna be, yeah, the default 200 megs. This one is gonna be our boot partition. What did I have set to BIOS? This is gonna be our boot partition. Highly recommended. Use this partition to store kernels and other booting information. To minimize potential boot problems with larger disks, make this the first physical partition on your first disk drive. Partition size of 200 megabytes is adequate. I think this is not to be confused with the grub BIOS partition, the boot disk. So it's different. The grub BIOS partition is different from the boot partition. So this is going to be our boot partition. So we're going to add that, and then make a new partition with, yeah, it's partition number 2. We're not going to bother with swap. We got 64 gigs of RAM. I hope we don't need swap. Maybe we're going to need twice the swap. I don't know. This is a learning show. We're going to do our grub partition. We're going to change its type for number 2 to be the BIOS boot. Well, should have been 19, right? Oh, that's the swap. That's why you always double check. It's 4 for BIOS boot. So we want partition type 4 for grub for the BIOS boot. We're going to make a new partition, number 3. First sector's fine. We're going to make this the root partition, so that's going to be 20 gigs. Then we're going to add user source, and then we're going to add 50 gigabytes for this fourth one. And for the 5th one, it's going to be opt, just going to be useful later. You'd think that coffee would make my head clearer. Sometimes it does the opposite. It just makes me jittery, anxious. Maybe that wasn't the best streamer drink. And then the remainder is just going to be our home partition. So partition number 6, first sector's fine. And then the last sector, I think, is going to be just everything else. This should be 20 gigs. So SDA1 is going to be for /boot. SDA2, that's for grub. SDA3 is root partition. SDA4 is 50 gigs. That's going to be our source code directory. Number 5 is opt, 10 gigs, and then everything else is home. Looks good to me. Yeah, this coffee's really kicking in. I'm jittering the fuck out. Write table to disk and exit. Creating a file system on the partition. Partition is just a range of sectors on a disk drive, delimited by a boundary set in a partition table. Before the operating system can use a partition to store any files, partition must be formatted to contain a file system. We're just going to use ext4. Just double checking to make sure, because when you format stuff, you got to make sure that everything's proper. So this is going to format our root partition to ext4. I didn't sudo it. Just making sure we don't run into any problem. You know, no. We should run into problems. We should make problems. Because how else are we going to learn why Google everything, right? All that's going to train us for is learning what Google tells us. We're supposed to get good. So I'm going to X for SDA1. We're not going to do it to grub because I think that has to stay unformatted. 1 and 3 can be that, and then 4, 5, and 6, same deal. I'm jittering the fuck out with this coffee. Okay, we're not going to bother with swap. Alrighty, so we formatted everything. Now we're going to set the environmental variable. Linux from scratch is going to need this, so LFS to be onto LFS. Throughout this book, the environment variable LFS will be used several times. You should ensure that this variable is always defined throughout the LFS build process. It should be set to the name of the directory where you will be building the LFS system. We'll use mount LFS as an example, but you may choose any directory name you want. If you're building LFS on a separate partition, the directory will be the mount point for the partition. Choose a directory location and set the variable with the following command. Having this variable set is beneficial in that the commands such as make directory verbose lfs/tools can be typed literally. Shell will automatically replace LFS with all that. Okay. So we're going to do that. We're going to set a file mode creation mask in case OpenSUSE here uses a different default. So the mask is going to be set to 022. Setting the umask to 022 ensures that newly created files and directories are only writable by their owner, but are readable and searchable by anyone else, but only for directories. Caution, do not forget to check that LFS is set and umask is set to 22 whenever you leave and re-enter the current working environment, such as when doing an SU to a root or another user. I don't think we have to worry about this too much, considering we're choosing to do this in a VM. It's kind of partly why I like doing it in a virtual machine, because it sort of contains everything. Yeah, so that should be fine. One way to ensure that LFS and umask are always set properly is to edit the bash profile file in both your okay, we're not going to bother with that. Mounting the new partition. Now that a file system has been created, the partition must be mounted so that the host system can access it. This book assumes that the file system is mounted at the directory specified by the LFS environment variable described in the previous section. Strictly speaking, one cannot mount a partition. One mounts a file system embedded in that partition, but since a single partition cannot contain more than one file system, people often speak of the partition and the associated file system as if they were one and the same. We're going to create a mount point and mount LFS with these commands. We're going to make a directory. P verba. What does P do? What does... Oh, of course, man pages doesn't exist on here. So we're going to do it in our browser. We're going to pin Roulette. Parents. No error if existing. Make parent directories as needed. So sudo make directory parents verbose from scratch, which is just going to make mount LFS. Create a directory mount LFS. And we're going to mount verbose tx4 to dev. I think this is the root partition, correct? So SDA3, I want to say, because SDA2 was grub. So we're going to want, okay, I think, cannot find it, what? It's right in front of me the whole time. Of course it wasn't working. So mount verbose type ext for the partition or the mounting point or whatever. And then we need to put, oh my god. This is Dicker's Tech Tips. Dude, how much time have we wasted from something that was just right in front of me? If I just read the thing, SDA3 mounted on Mount LFS. Okay. Moving on. If you're using multiple partition, oh yeah, we should mount multiple partitions. So we have this for our root partition. Then we're going to do boot. So LFS boot, right? Oh, right, because we should probably make that LFS LFS boot. Oh, we're not root. We're not doing it as root. There you go. So we want LFS boot. Got the root partition. We'll do user source. Created the directory. Do opt. And we'll do home. Alright. Getting comfier. We're going to mount number 1 to LFS boot. We're going to mount 4 to LFS user source. 5 to opt. And then 6 to home. Okay, set the owner permission mode of the LFS directory, root directory to root, and 755 in case the host distro has been configured to use a different default for makeFS. So chown root LFS. Oh, I keep forgetting because it doesn't say so in the thing. We gotta do that stuff as root. Sudo change mod 55. Oh shit. Okay. Ensure that this new partition is not mounted with permissions that are too restrictive, such as no SUID or no dev options. Run the mount command without any parameters to see what options are set for the mounted LFS partition. Yeah, okay. How do we do that again? Can I just do out without any parameters? Okay. So SDA3 is our root. We have rewrite and fill time. I think that's fine. See this other, okay. So these are the ones like the no SUID, no dev, no exec. These are the ones that we don't want, but as we can see, we don't have all the extra ones that we don't want. The no SUID and no dev ones specifically. So it should be good on that. The above instructions assume you will not restart your computer. Yeah, we know. We're all good. If you're using a swap partition, we're not. Maybe, hopefully that won't cause any problems. Okay. So, major milestone. We're in chapter, I guess chapter 3. So that's it for chapter 2. We're doing chapter 3. We're going to keep going. Packages and patches. Introduction. This chapter includes a list of packages that need to be downloaded in order to build a basic Linux system. The listed version numbers correspond to the versions of the software that are known to work, and this book is based on their use. We highly recommend against using different versions because the build commands for one version may not work with a different version unless the different version is specified by an LFS erratum or security advisory. We're not going to connect this to the internet, so I don't care so much about, security advisories and things like that. It's a self-contained virtual machine. Let's see. Some packages that release from applications may not be accessible. Download packages and patches will need to be stored somewhere that is conveniently available throughout the entire build. A working directory is also required to unpack the sources and build them. LFS sources can be used both as the place to store the tarballs and patches and as a working directory. By using this directory, the required elements will be located on the LFS partition and will be available during all stages of the building process. So let's create that directory now. Oh wait. And we're going to remember to do sudo this time. LFS sources. Created a directory. Make this directory writable and sticky. Sticky means that even if multiple users have write permission on a directory, only the owner of a file can delete the file within a sticky directory. Interesting. There are several ways to obtain all the necessary packages and patches to build LFS. We're just going to use wget, or wget, however you want to pronounce it. What is this? Ah, probably a more eloquent way to do this, but it works. This is going to give us all the files. It's a separate file, MD5 sums, which can be used to verify. Okay. Okay, I don't know how long this is going to take, so back to Roulette. We're going to start a new batch here. Start with $1,000 bets on black. Red. That's okay. We're going to stay committed, okay? There, see, what did I tell you? Nobody got anywhere being a flake. True to the black. Okay. So we lost that time. You can't win them all. We're gonna go odd. Black again. Even. 500 on red. Black. Even. Okay. No, I don't... Winter roulette? Why not? You know what? It's January. We're doing winter roulette. Oh, did you look at that? We're gonna do it all on odds. Fuck you. Gonna do second on evens. Massive win, 5K. Okay, we're back. We're gonna make it back. Heal 3, massive win. We're making it back. Fuck off. $2,500 spin. Dark blue set. There you go. Massive win. We're gonna go dark blue again. God damn it. It knows. It fucking knows. Heal again. Out of credits. It's okay. It's not real money. It's not real money. There you go. Massive win. See, we can... There you go. Okay, we're coming back. I think our time is returning. Fuck. Okay, maybe we don't want to do that. Display output is... Okay. Go. Oh! Can you rig a free flash game? Is this something they do? Does this have like a house edge that I'm not aware of? Yeah, we are on a massive losing streak right now. Okay, new plan. If I think something is a good idea, we're going to do the opposite. So I want to do dark blue, which means we're going to do teal. God damn it. Okay. I want to do evens. So we're going to do odds. We're going to go all in on odd. Okay, so I was right. That can be a curse sometimes. Sometimes you're so right, you're wrong, actually. So we're going to go all in on the first third. Okay. We're going to do a 5K bet on our periphery. Massive win. So maybe we should start doing that. Periphery. I'm going to focus on the odds and go on even instead. I'm not even going to look at it. God damn it. 5K on... What are the... The odds are pretty high, actually. That would happen. Okay, well, fuck you then. 500 plays. 25. I am getting fucking just curb stomped today. There you go. Hey, there you go. Yeah! Okay, we're back. Massive win. Damn it. 4K win. We're up to 16K. God damn it. Yeah! Okay, new record. We're almost up to 20K, guys. Yes! Okay, now we're up to 20K. So let's look at the board here. Okay, our mojo's coming back. It's okay. That's why you do low spins sometimes. You only do $1,000 spins sometimes. Ah. There you go. Okay, we're gonna do 5K evens. Hey! Massive win, 10K. So now we're gonna do, there you go. Don't want to try your luck too much. I'm gonna do odds. Ah, that's okay. We'll make it back. Massive win, 1400. Teal 1. Massive win. This is probably gonna be... Ugh. Dude, come on, dude. You kidding me? You serious? Motherfucker, I would have made 5K. That's okay. Well, there you go. There you go. Make it back. Damn it. Damn it. Hey! 21K. We're back. Fuck. Yeah! Yeah, there you go. Massive win. Very nice. Okay. We're on a fucking streak today. Dude. I'm a fucking gambling god today. I say as it. Okay. Dark blue. Okay. Hey. Massive win. Massive win. Okay. Okay. We got this still. We got this still. Shit. Massive win. Okay. Anybody who doubted me, check this shit. Massive win. We're up 50K. We're up fucking fat today. Holy shit. Let's do another odd. $1,000. Massive win. God damn it. Oh, god damn it. Yeah. Yes. Yes. God damn it. Alright. We're so back. We're so back. Almost 100K, guys. It is over. It is so fucking over. It is so fucking over. God fucking damn it. Yes! Okay, we're gonna make it back. Fuck. I lost it all. God damn it. Okay, how are we doing here? How many of these? Okay, so we're not even halfway done. We could probably do another round. Can we beat our last score? We almost hit 100K that last time. 100K. Let's see if we can do it again. Okay. Okay. Fuck you too. It's just gonna take a while to download these, packages, so might as well do something to pass the time. And it's not real gambling. Okay, it's just a flash game, so it should be fine for Twitch. I think. We'll know if they ban me. Oh, there you go. Ugh, lost it all. Fucking lost it all again. It is so over. It is so over. I lied, we're actually up. Oh, god damn it. Jinxed it. There was no way. Oh shit, are we getting read errors? Oh, I wasn't even paying attention to this. So some of these packages, they're not even downloading. That's a bit of an issue. Are there alternative mirrors? I probably should have checked that. All right, let's see here. Download locations may not always be accessible. The download locations changed since the book was published. Google provides a useful search engine for most packages. If the search is unsuccessful, try one of the alternative means of downloading. Probably should have that open. So I'm going to take a quick check here. So it's just Gawk, I guess. Gawk and, okay, back to gambling. It's so... We're so back. So over. We're so back. We're so back again. Dude, we might actually make it this time. No, it's over. It's over. We're gonna lose it all. No, I lied. We're back. We're so fucking back. No, it's over. For real. I'm gonna fucking do something stupid later. No. Yeah. It's the apocalypse. We're... what is going on? Can I skip this? I don't know how to skip that. Yeah, would Control-C skip this or just cancel the whole thing? I kind of don't want to do that. So it appears to me that ftp.gnu.org worked fine earlier. Maybe not so much right now. The gambling shtick, I mean, that works for a little while, but if it's going to be for extended periods, we're going to have to think about maybe doing another thing. Maybe we should, we could switch gears to the Steam Deck stuff. Alright. So, ls. So what do we have? We have some patches. We have most of the packages. We should have most of the stuff from before. I'm just gonna do a quick head count here. So we got ACL, we got attribute. We don't seem to have GCC. We have glibc. We don't have GCC. We don't seem to have GDPM. So there's probably some kind of like grep thing that you can do with awk, or we can like compare stuff. If I were to do like, if I do like an LSAL, right, and then we just compare the output of that. Because if this doesn't work, I mean, we're just gonna have to find a mirror. So everything looks okay. Did I install any duplicates? I think we're ready to roll. Okay, so we're gonna chown just in case. Alright. All packages. These are all the different packages that we just did. And there's patches. We got those final preparations. So we're at chapter 4. This chapter we will perform a few additional tasks to prepare for building the temporary system. We'll create a set of directories in LFS, add an unprivileged user, and create an appropriate build environment for that user. We'll also explain the units of time, SBUs, we use to measure how long it takes to build up the LFS packages, and provide some information about package test suites. In this section, we begin populating the LFS system with pieces that will constitute the final Linux system. First step is to create a limited directory hierarchy, so that the programs compiled in Chapter 6, as well as glibc and libstandardc, C++, can be installed in their final location. We do this so that those temporary programs will be overwritten when the final versions are built in Chapter 8. So we're going to create the required directory layout by issuing the following commands as root. LFS, let's see. I think we might wrap this up. I think I'm coming down from all that coffee. I'll do this last command, and then I think that'll be it for today anyways. Oh. You know what? I'm gonna do this. Paste this with anything. No. Alright. Well, guess I could just write it. God, that's... Okay, I think we're good. Oh, oops. Alright, there you go. Programs in Chapter 6 will be compiled with the cross-compiler. More details will be found in Section Toolchain Technical Notes. This cross-compiler will be installed in a special directory to separate it from other programs. Still acting as root, create that directory with this command. Okay. Sudo make a directory, pv. LFS tools. Create a directory, LFS tools. Deliberately decided not to use user lib64 directory. Several steps will be taken to ensure the toolchain will not use it. If for any reason the directory appears, either because you made an error in following the instructions, or because you installed a binary package that created it after finishing LFS, it may break your system. You should always be sure this directory does not exist, so keeping this in mind, you should never, ever, ever have a user lib64. Good. Just to be safe. Excellent. Alright, I think that might be it for today. It is going to be about 5 o'clock. I think this was a good stream. We actually did what we said we were going to do. Oh, and as soon as I'm about to leave, I get 3 views. Nice, I get one more viewer. Came a little late, I'm afraid. Alright, outro time. See you next Friday at 12.